For this question, you can refer to the in-class discussion question number 1 on page 229. So part A asks, as you push down on the syringe, how does the membrane covering the test tube change? And we can infer that the air pressure inside and outside the test tube is the same because the membrane is level. And then as you push down on the syringe, more particles will be inserted into the container containing the test tube. And then when there's more particles, the atmospheric pressure will be greater, and which will make a greater pressure on the outside of the test tube than there is on the inside of the test tube. And so the membrane would collapse and be concave, as shown right there. And then part B asks, if you stop pushing the syringe down but continue to hold it in a few seconds, what happens to the membrane? And the membrane would stay concave like that because the air pressure would still be greater on the outside of the test tube than it is on the inside of the test tube. And that is the discussion question number 1. For this question, you can refer to the in-class discussion question number 3 on page 229. So the question asks, if the atmospheric pressure stays the same, how high will the levels of mercury be in the other barometers? And you can see for the other barometers, the area changes in them. And so for the equation, pressure equals force over area, the pressure has to stay the same, and if the area is changing, then the force needs to change with the area to keep the ratio the same, so the pressure stays the same. So the levels of mercury in all the barometers will be the same height in order to keep pressure constant, as seen by this drawing.